going to learn how to decompose a congressional bill and see the earmarks using machine learning. I took a 1,050-page omnibus bill and reduced it into 827 instances of top-line spending. Then I visualized the bill in 3D space, locating all the dense sections. Hello world, I'm Data Mining Mike, the very first data scientist to do this. In this video, I'm going to teach you how to see a congressional bill in 3D space using K-means cluster analysis. And if you want to learn more about how K-means works, check out this video up here. This video follows along with a scholarly blog article which you can find a link in the video description below. I am highly confident at the end of this period of instruction, parsing through a congressional bill will no longer be a daunting task. And that's called value. The first thing I did is decompose the Word document into tabular format. After quickly glancing through the bill, you can notice how the congressional bills are structured. They're structured with divisions, titles, and entities. A bill is a reverse budget, with the top line items being the entity or department that will be receiving the monies. Here is the alpha process for data mining of the bill to reduce it down and see it in 3D space. In this section right here, I upload all the libraries that I'm going to need to include word cloud, because word cloud is going to be interesting, so we're going to be able to identify the words that associate with the earmark. From docx, import document. In this section right here, I am importing the text file and converting it into a data frame. So the result is the text file with one column of text wrapped through it, descending in every single row. The total shape is 10,986 rows. Here is the functions I needed to reduce the text into its separate entities with agency. So right here is the function to extract the capitalized words using the regular expressions function, or reg or regex. Here is that code to find all of the capitalized words. Here is the function to find the title associated with each agency in the bill. And I found this because I know that each title has a Roman numeral associated with it. Utilize this function and get a better output of what we needed and parse through the bill. Here's the function to extract the highest amount. Goes and finds the title, the section, the title, and it goes and it finds the highest amount. So now I apply these functions to the text, to the title, to the highest amount, and I have my data frame. From this data frame, I see it's been reduced. A 1,050-page bill has been reduced to 827 instances of spending, and we have 5 columns. I save this because there's going to be additional cleaning that's going to be needed before I upload it into the data cleaning process Bravo. Here is where I'm exploring the words in word cloud for the bill. We can tell that provided is probably the biggest indicator of an earmark. Word, the size indicates frequency. We can start to articulate like a bill by saying things such as, the authorized available payment for public law facilitates research heading activities with the status code supporting the U.S. provided section of the paragraph. The available use salaries of the program have a percentage made available for the purpose of the expenses of the fiscal year. The amounts made to the state's code and national amount for the authorized use costs is in addition to public law payments, provided that the available support in the research facilities and the activities, including transfer. That's how to sound like a congressional bill. Data cleaning process Bravo. Here's where I import the data set. Here's where I inspect the data set, and I notice that we have this /t, so I have to do additional cleaning to get rid of that /t, checking out the shape, 827, getting descriptive statistics. So we have 5 columns, and we can tell what their data types are: objects, floats, objects. What we're going to need to do is we're going to have to convert all those objects into binary prior to exploration in machine learning. We inspect the number of missing rows. In this section right here, we're converting all of the titles and divisions to binary, and they're transposed, so it's giving me this sort of specific layout and view. This is the variable. Agencies are top 20 earmarks, where I'm getting the largest 20 of the highest amount and the text that is associated with the highest amount. Here is the output of the 20 and where to find it. This is the highest amount given. $998,000. The Act of 2008 provided further that. So if you want to find that portion of the text in the bill, all you do is copy that and then look it up in the Word document. Or you can find it right here, Section 251 or Section 165, or land and water claim settlements. Now, in this portion of the code, I'm exploring each division. In this portion, I'm looking for Division A, and I notice this bump right here, this bump in the tail. Go down to Division B, a bump in the tail. Division C, bump in the tail. Same with D. What is the bump in the tail? The bump in the tail is called Benford's Law. Benford's Law is a accounting sign that people are stuffing money into the tail end, because the tail end should be smooth. So whenever you see a bump like this, you know that something's wrong. And that is called Benford's Law. Benford's Law is efficient for finding campaign finance fraud for politicians, because they tend to use the tail ends to stack a bunch of super PAC money saying that it came from individual donors. That's one example of Benford's Law in action. And in this specific case, it looks like they're really stuffing whatever portion of each division of the bill is getting really stacked in this tail end here. That's something to investigate later. Now I go into unsupervised machine learning using PCA to transform the variables before exploring them in k-means. I decompose both divisions and titles. Here are the divisions in k-means. We can see the divisions as per 2 groups, 3 groups, and notice how they're separated out in vector space. We can see them in vector space. Now if I go down to, as we start off with 1 group, we see a blob. Move to 2 groups, we see a blob, but starting to form out a little bit more. 3 groups, we can start to see this rectangular shape here, and we can start to see how the divisions are separated from the bill itself. And we can start to see this shape of a rectangular paper bill. So as we add more groups for it to inspect, we say, hey, I want to see 4 distinct groups. K-mean says, here's 4 distinct groups, and it's isolating this strata and this strata. And we can tell that the density is right here in this area. Moving down to 6 groups, we can tell that it's isolating this piece of strata as an area that's different from other groups for further investigation. And then as we move to 6 groups, we can tell that it's isolating this piece of strata as a different group. And with all of this information, decomposing a congressional bill and finding the densities for further exploration is no longer going to be a problem. I am highly confident now you're going to be able to take what you've learned and be able to decompose any sort of text, whether it's a bill or a book, into vector space and see the densities. See like the machines with k-means. I'm Data Mining Mike. Be sure to like, subscribe, and smash that bell for more data-driven updates. Bye!